Okay. So, we've been talking about lines, and we've still got plenty of things to say about lines. But just as a recap of what we've already said, first we have the point-slope formula. So the point-slope formula for the equation of a line. So what's it's the title of it. It's named after the information that you know. So you're given a point x1, y1 and a slope little m, then the situation looks like this. A situation like that. Then the formula is y minus y1 is equal to m multiplied by x minus x1. All right. That's the point-slope formula. And then as a special case, if the point that you know happens to be a y-intercept, then that's a special case, and that one is called the slope-intercept formula. So the slope-intercept formula for the equation of a line. And again, it's named after the information that you have. So given a slope m, and a y-intercept 0b, so the picture looks like this. So again, slope m. And then we also have a point, but there's something special about this point. So rather than the point being situated anywhere on the line, it happens to be situated exactly on the y-axis. So in that case, the formula is y is mx plus b. And then sort of as for both of these, there's sort of a special case in the case that what if the lines are vertical? So I'll just mention that I'll remind you that we mentioned the vertical cases. Okay. So now we're going to get at the maximum level of abstraction, and we're going to sort of write a page that says everything that you could want to know about a line on the plane. So every line is the graph of an equation of the form ax plus by equal c. And we've got a couple of requirements. So where a, b, and c are constant, so those are just some numbers, like maybe 2x plus 3y equal -8, something like that. And a and b are not both 0. So understand what that means. It means that it's fine for one of them to be 0, but if one of them is 0, then the other one isn't. The reason why is because if they were both 0, if a and b were both 0, then what would the left-hand side become? Just 0, right? And then there wouldn't be any variables. So we can have one of them 0, but not the other. All right. So now we're going to consider three main cases. So the rest of the page is going to be in 3 columns. 1, 2, 3. All right. So the case that that a is 0. Now, according to that rule, it's saying that they can't both be 0. So if a is 0, understand that means that b isn't. So therefore, b is not 0. And I'm going to take this equation and essentially plug in a is 0. So it would look like 0x plus by equal to c. Of course, I can just drop the 0x. So then it looks like by is c. And now I want to solve for y. So what do I need to do to solve for y? Divide by b, so that it looks like y is c over b. Now, so we needed to perform a division. Is that division legal? Alternatively, under what circumstance would division by b be illegal? If it's 0. So is it legal?
Yes.
Yeah. Why?
Because we've already established that a is 0, therefore it cannot be.
Right. So that right there is the permission to proceed in that way. Okay. So now, a, b, and c are constant. Those are all constant. And so in particular, that's a constant, and that's a constant. So what I want you to see is that we're at an equation that looks like y equal constant. So now, if we had like 20 folks up here, and they were all maybe they were exactly 5'9" or something like that. Everybody's the same height, and we put everybody just shoulder to shoulder. Then you could take like a 2x4, like a piece of wood, and you could just gently just set it right on top of them, and it'd be touching every one of their heads, and it'd be exactly level, because everybody's exactly 5'9". Okay. Well, that means that if we plot this, y equal to a constant, it'll be like here's one person, here's another person, and I'm just saying the top of their head there. Here's another one, top of their head, top of their head. They all have the same height. So the result looks like this. So specifically, maybe left to right, this point is maybe something like 5. So left and right, it's 5, but how high is it? C over B. And maybe this point right there, left and right, maybe it's its x coordinate is 1, but what's its y coordinate? C over B. They all are, right? Every y coordinate is C over B on that line. That's what that means. All right. So that's one case. What about the case that B is 0? So, by analogy or symmetry or whatever, just like this one, if B is 0, then what? Then A isn't. And so I'll plug B in, B equal to 0 in, so that we would have something like AX plus 0y is C. Then we can drop the 0y so that it reads like AX is C. Then we can solve for x and obtain that x is C over A. And again, what's the permission to perform that division by A? Right there. That's what makes it legal. And because A, B, and C are all constant, this is a constant. So we're looking at x equal to a constant. So, instead of all the y coordinates being the same, like this, now it's going to be all the x coordinates are the same. So what kind of line will we have here? Yeah, a vertical one, as you say. So maybe something like this. All right. So again, we could have several points. So maybe this point right here, maybe maybe that point is at height 2. So it would be something comma 2. Something comma 2 because it's at height 2. What's its x coordinate? C over A. And then if I choose a point down here, well, that has a negative height. So maybe it's something like something comma -1. But what's its x coordinate? C over A. Because, that's what it means to be vertical. That's what it means for the equation to read x is C over A. X is C over A for all of those coordinates, every single one of them. Any question about that case? So the last case is the case when A is not 0 and B is not 0. Now for those of you who are trying to enumerate through the cases, you might think, well, wait, what about the case when, if we're doing this one 0, that one not, this one 0, that one not, neither one is 0, then what about when they're both 0? Well, we specifically said that's not allowed. So that was just crossed off the list. So if they're both not 0, then let's solve for y. So, ax plus by is c. So then by is negative ax plus c. Moving the ax to the other side. we want to solve for y, so what can I do now?
Divide.
Divide by b. Of course, the permission to do so is right there. So we divide by b, negative ax plus c, and then all of that over b. And then we can distribute that division in to obtain y is negative a over b x plus c over b. And again, these numbers are constant. Now, if you look at the previous page and compare these two, then you know the slope-intercept form is y is mx plus b. So generally, y is constant x plus other constant, where that one is the slope and that one is the y-coordinate of the y-intercept. So just using that comparison, that's telling us that in this case, this is the slope. That's the slope of the line. And this is telling us that 0 comma c over b is the y-intercept. Can you see it? All right. So we're talking about some kind of sloped line there. Something like this. So not horizontal, not vertical, something intermediate. And you know, it's saying that the slope of this line is negative a over b, and it's saying that that point right there is 0 comma c over b. All right. So now a few qualitative questions before we get to the next part. So as I drew this one, as it's drawn on the page, you know, it's of the form y is a constant, and in principle it could be any constant. It could be negative, 0, or positive. But the way I drew this is c over b negative, 0, or positive, according to the way it's drawn. Positive. So why is c over b positive, according to the way it's drawn? Yeah, because it's a horizontal line that's above the origin. So it's up here, so it's positive. If it was down here, it'd be y equal to some negative value. Similarly, this is x equal to a constant, and in principle that constant could be anything, negative, 0, or positive, but I had to draw something specific. So according to what I actually drew, is c over a negative, 0, or positive? Sorry? Negative. And why is it negative? Because it's over there, right? Because it's on the left side. To be positive, it would have to be over there. All right. Fine. And now, here's the one that I've purposefully done to kind of bend your brain a little bit. So when we talked about lines, we said, well, there's different categories of slope. And we came up with 4 categories. We said that the categories are negative slope, 0 slope, positive slope, and undefined slope. We said, here's the 4 kinds. And then what kind of slope, you know, just according to the way I drew it, that one right there, which category does it belong to? Positive, right? Of the four choices, negative, 0, positive, undefined, that one is positive. All right. So now, according to the formulas, the slope is negative a over b. And the way I drew it, the slope is positive. So I have a question. Is it possible for negative a over b to be positive? So I'm getting some not very confident responses. So let's back it up just a little bit and just say, suppose we've got some number p, and p is just some real number. Is it possible for negative p to be positive? Okay, under what circumstance would negative p be positive? For an example circumstance.
P is negative.
Yeah, if p is negative. So if we've got some number p and it's like negative 8, the negative p is negative negative 8, which is positive. Is it possible for negative a over b to be positive? Sure it is. If a and b are both positive themselves, then a over b would be, if say a is negative and b is positive, then a over b would be negative, and negative that would be positive. So, you got to think through all the negations, double, triple negations, and think, okay, well, where am I? Okay, fine. Also, the way that this is drawn, c over b is just a constant. In principle, it could be negative 0 or positive, but the way I drew it, c over b is at negative 0 or positive, according to the way I drew it. Positive. How can you tell that c over b is positive? Yeah, because that point right there is above. Now, if I took this whole ensemble and pulled it down a little bit so that that green point was right there, then c over b would be a negative value. All right. So that being said, if additionally c is 0, then and continuing these columns, then, from here we have y is c over b, so we could continue this and say that, well, y is actually 0 over b, which is, of course, 0. And we said that, if it's y equal to a positive constant, it's up here. And if y is a negative constant, it's down here. So if y is exactly 0, then where is it? Yeah, it's on the axis. So I'll draw that just barely above it, because if I drew it exactly on it, you wouldn't be able to see it. All right. In this case, if c is 0, then continuing that equation, x is c over a becomes x is 0 over a, which is, of course, 0. And, we said that, well, if x is a negative constant, it's on the left side. If x is a positive constant, it's on the right side. So if x is exactly 0, then where is it? Right on top of the y-axis, right? Okay. Fine. And then now continuing this equation, if c happens to be 0, then it would read y is negative a, negative a over b x plus 0 over b, which you could write it like this: y is negative a over b x, and you could just omit the 0 there. Then in this case, we said that well, if c over b is positive, the y-intercept will be up here. If c over b is negative, the y-intercept will be down here. So if c over b is exactly 0, where will the y-intercept be? At the origin. And this last one is the punchline, is the key insight. Is that observe that for all of these lines, in fact, they all go through the origin. That one goes through the origin horizontally. This one goes through the origin vertically, and that one goes through the origin with some slope. So that's what c equal to 0 means. It means through the origin. And if you get excited about math and you take a bunch more math courses, then eventually this starts to be you get more and more technical vocabulary, and such lines that pass through the origin, they're said to be homogeneous, and that becomes important a little later, but not for us, not in our class. Good. So this is in some sense, this page says just about everything there is to say about lines right there. But it helps to single out one more aspect until we can do something concrete. So one more kind of abstract thing. So it is the definitions of parallel and perpendicular. So those words mean exactly what you already know them to mean, but we need to carefully define them. So parallel. So two lines are parallel if they're two different lines, if they're not exactly the same line, then they have to sort of run side by side and never intersect. And then, of course, a line is parallel to itself, right? But it intersects itself at infinitely many places. So we'll break it down into two cases. So here's sort of the normal case. So we've got a line here. Y is m1x plus b1. So that's some line. And now we'll have some other line that's not the same line. So this is y is m2x plus b2. And now the question is algebraically, what must be true in order for these lines to be parallel? It's going to have something to do with the slopes. What must be true? Have to be the same. Not so, sort of what the intuitively obvious thing is that they have to have the same slope. Which is to say that m1 is m2. All right. But there's another possibility. There's another way in which lines can be parallel. And this one is sort of like an eye roll. Like, you know, you may be having difficulty imagining another kind of way that lines can be parallel. But you've got to look at consider the situation carefully. So understand that this situation over here is saying that suppose we have two lines, and suppose that these lines have a slope. Then in order for them to be parallel, the slopes must be the same. But you know, the thing to overlook is that do all lines have slope? No, right? Not all lines have slope. What kind of lines don't have slope? The ones with undefined slope, the vertical kind. Right? So either they have slope and the slope is the same, or they both have undefined slope. All right. Good. Perpendicular. So now perpendicular is sort of like the opposite of parallel. But you know, it's like to be understood opposite in sort of the most possible way. So like these are parallel as I'm holding them, so they're parallel, and this isn't parallel, right? Because they're crossing. But these are not perpendicular. So for perpendicular, we want them to cross, but we want the angle of the crossing to be you know, sort of as marked as possible. And so we want the angle to be a right angle. That's what perpendicular is going to mean. It means that they have to cross somewhere, and moreover, that crossing is at a right angle. Okay. So again, there'll be two cases. So we've got a line, y is m1, x plus b1. And we've got another line, which is going to cross and do so at a right angle. Y is m2, x plus b2. So that crossing is a right angle. And just like up here, you know, up here we had an algebraic condition. What must be true about the slopes in order for the lines to be parallel? Well, they have to have the same slope. And now what we want is a condition on the slopes that must be true in order for them to be perpendicular. Now this one is much less obvious. And if we have time later, I might go over exactly the reason why what I'm going to write down is the condition we're looking for. But for now, I'll just write down the condition. So the condition is that we need to be able to multiply these slopes, m1 multiplied by m2, and the result, the product of the slopes, has to be -1. So you multiply the slopes together and you get -1. So that's the mathematical condition. And then for the purposes of problem solving, it's usually not written that way. Usually you take that condition and you solve for one of the slopes. So maybe we'll solve for M2. So if we solve for M2, then what do I need to write over here? Right, so negative 1 over M1. So that's solving for M2. And so in language, what's typically said is that the slopes are negative reciprocals. Okay. So that means, you know, this is the condition, and then here's a nice formula, and then here's a way to say it out loud. And you can sort of break it into two different requirements. The slopes must be negatives, and they must also be reciprocals. So examples of this would be like if we had a slope 2/3, then if we did negatives alone, just negatives, then you know, it'd be negative 2/3. If we did just reciprocals, what's the reciprocal of 2/3? 3/2. Okay, but to get the perpendicular slope, we need both. So what slope is perpendicular to 2/3? Well, it'd be negative 3/2. Negative reciprocal. All right. What about what is the perpendicular slope to negative 13 over 14? 14 over 13. You know, because you've got a negate, so that squashes that negative, and then reciprocal. So flip it like that. So what about what is the perpendicular slope to 5? Negative 1 over 5. So the most common mistake that students make is they do just negative or just reciprocal, but not both. The other possibility, just like up here, we had that case or that case. Here we're going to have this case or this case. So again, what's happening here is that this case is that it's saying, suppose that we have two lines and they both have a slope, and we want them to be perpendicular. Then the slopes must satisfy this condition. Okay? But not all lines have slope. So what is the other possibility here? Right. So we could have a line like this. So maybe this is something like, maybe this is y is a, say, and this one is x is b. And these are at right angles. Okay. So one with slope 0, one with slope undefined. All right. Any question about this? Okay, so then using these, here's a typical situation. Is something like this. So let P equal to, say, I don't know, -5, 2, and Q equal to 3, -7 be points. Find the equation of the line Okay, now I need to describe the line that we're looking for. So find the equation of the line through the midpoint of P and Q and it needs to be perpendicular to the line segment. From P to Q. Okay, so a description of the line that we're looking for. All right. So, sort of the ideas or discussion without solving it yet. Just making sure that we understand what needs to occur. Is that we need to find the equation of a line, and we have two formulas for such equations. One of them, the first one we learned, is the point slope formula. And the other one is the slope-intercept formula. All right. And remember that the slope-intercept formula is really just a special case of this one. It's the special case when the point that you know happens to be an intercept. Now, in the description here, did we say anything about intercept? There's no mention of intercept. As a result, because there's no mention of intercept, it's unlikely that we're going to use this one. It's unlikely. It's not impossible, but it's unlikely. And because there's only two possibilities, more or less, that means that this one is quite likely. So we're probably going to use that formula. Second, to give ourselves a picture, a sketch of what's happening. We were given 2 points. Given 2 points. And if here's the axis generally, then I'm going to just plot generally where they belong. I'm not worried about exactly where they belong. So in which quadrant is P? And you can say, left, right, bottom, top, whatever. So where's P? So it's in quadrant 2, which is on the left side because of that -5. So the left half and the top half. So it's in the left top. So it's up here-ish, maybe. So like this is like P here. And then in which quadrant is Q? It's in quadrant 4 because it's on the right half and the bottom half. Okay, so maybe this is Q right here. So there's Q. Again, I'm not trying to I'm not at all trying to get it exact. I'm trying to make sure that they're situated left and right, top and bottom properly. So are we supposed to find the line that goes through P and Q? No. It's supposed to go through some other point. What point is it supposed to go through? The midpoint. Right, the midpoint of P and Q. All right. So here's like the line segment. And then just eyeballing it, the midpoint looks to be like right there-ish. Okay? And, you know, I didn't carefully plot that, so that doesn't mean the midpoint is going to be in that quadrant. I just wanted to make sure that I had P and Q in the correct quadrants. So, you know, we're saying that we want to go through that point. So we want a line that goes through that point. And, you know, there's lots of lines that go through that point. There's infinitely many lines that go through that point. Here's one. Is that the line that we want? So that's a line that goes through it. Is that the one that we want? No, that's not the one that we want. Why is that not the one that we want? Yeah, it's not perpendicular, right? It says, the instructions say, find the equation of the line through the midpoint of P and Q, so we want to go through there. That's good. But it also says it needs to be perpendicular to the line segment from P to Q. So it needs to be at a right angle to this. So through there, and moreover, at a right angle. So through that point, and moreover, perpendicular. So do you get the idea? Now, for that reason, it seems to me even more likely that we're going to use the point slope formula, because literally the description says through this point and with that slope. So, you know, that's pretty good. It's pretty good suggestion. All right. So for the point then. So the point that we're looking for, x1, y1, is going to be midpoint. And remember that midpoint is average, so that'd be p plus q over 2. So we need to average those 2 points. So in the first coordinate, we will want to add those two things up. So that'd be -5 plus 3 divided by 2. So that's the average x coordinate. And then 2 plus -7 over 2. That's the average y coordinate. So then x1, y1 would be -1 in the first coordinate, and -5/2 in the second coordinate. Okay, so that's the point that we go through. So in fact, I didn't get the picture right. The midpoint's actually in the bottom right, but that's okay. All right, that's the point. Now as for the slope. So this is going to be a two-step procedure. So we're asked to use slope which is perpendicular to that line segment. So the first thing I'm going to do is find the slope of that line segment. So slope from P to Q. So delta x, the change in the x's, so 3 minus -5 is 8. And then delta y would be -7 minus 2 which is negative 9. And so the slope from P to Q is negative 9 over 8. So is that the slope we're looking for? No, right? That's the slope of this thing. We want the perpendicular slope. So the perpendicular slope would be what? 8 over 9. And now we can wrap it all together. So the equation is then, so here's the formula, y minus y1 is m multiplied by x minus x1. Now it's just a matter of plugging in the stuff that we found and simplifying and what have you. So y minus negative 5/2 is equal to 8/9 multiplied by x minus negative 1. So y plus 5/2 is 8/9 x plus 1. So y plus 5/2 is 8/9 x plus 8/9. And then solving for y is 8/9 x plus 8/9 minus 5/2. And I guess now we need to find a common denominator, and then we can be just about done. So this one has denominator 9, that one 2. So what's the least common denominator? 18. So then we could say that this is plus 16 over 18, and then minus 45 over 18. And then subtracting those, what do we get? 29? That's weird, but it happens. 8 over 9x, and then subtract 29 over 18. So there's the answer. Very good. So I hope you have that's all the time we have. I hope you have a wonderful Monday.